Good.
Okay. So I'm going to share my screen now and then we'll get started. All right, can you all see my screen?
We do see.
Okay. All right, so today's tutorial is on heat map. Heat map is also another visualization tool that uses coloring to show variance across multiple variables. Okay. It's helpful in detecting patterns and showing similarities between variables, right? And also to identify correlation between variables. Okay. And it always comes with a legend that helps in reading. So a legend is more or less like a label, or yeah, sort of like a label to read and understand the plot or the heat map, the graph. Okay. So as usual, we are going to import our relevant libraries, loading the data, and then we'll create a pivot table. So we are going to, and we will do the heat map on the pivot table. Okay. So we are creating a pivot table. We want, so our data set is the MPATs, which is employee attrition, and then our values of interest is the satisfaction level. We want our index to be department and columns to be number of projects, right? So we want to identify the satisfaction level across department and number of projects. Okay. So now we create our first heat map. Okay. So before that, when we take a critical look at this pivot table, what do we see? Do we see a pattern over here? We realize that employees with 2 projects have a satisfaction level of about 0.4, 0.4, 0.4, 0.4 throughout the department. When it comes to 3, it's around 0.6. When you go to 4, it's around 0.7. When you go to 5, it's around 0.6, and so on and so forth, right? But when it comes to 6 and 7, it declines. You see 0.2, 0.3, and then as for 7, it's even worse. Okay, so at least when we look at the numbers here, we can see a pattern. How do we visualize this? How do we see this in a form of visualization? That is where heat map is very important. It comes in, right? So so we're using the heat map method in how do you call it, in Seaborn. Okay, so it takes in the pivot table, which in this case is table, and then annotation we set it to true because we want to see the numbers in the graph, and then we want it at 3 floating points, which is to 3 decimal places, and then the annotations font size. The annotation font size is 12. We set that one to 12, and then we have the label, X label, Y label, and then the title. Okay, so when we look at the graph, we can see that. So based on the legend, so this is the legend. 0.7 is very light and 0.1 is very dark. So you can see the transition from a very dark area to a very light area, right? So realize that the very lighter areas represent the optimal number of projects that employees with high satisfaction level have. Okay, so we see that over here between 3, 4, 5, you have it represents a very lighter area, and then this is relatively darker compared to this side, and this side gets even darker, right? So you can see that. So by looking at this visualization, we see that the optimal number of projects to be given to an employee at any given time is between 3 to 5, or 3 to 5, 3, 4, 5 projects. If it's more than 5, then their satisfaction level is dropping, right? So this is a real insight that you can see. Okay, now we go to the second heat map. So the implication is that assign 3 to 5 projects to employee to ensure optimal satisfaction level among them. Lesser projects will make employees feel less challenged. More projects will make employees burn out. Okay, so that is the implication, or that is the interpretation for this, the interpretation and implication for this graph we have over here. Now we're doing the same thing, but this time we want our values to be last evaluation, still on department and number of projects. Okay, Now, when you look at by looking critically at the figures, you can see that there's a rise. So the higher the number of projects, the higher your evaluation, right? Now, when we look at that on the heat map, you see the same thing. Okay, you see that it starts from a very darker place, then it becomes light, it becomes light, it becomes light, it becomes light. So this is why we say that heat map also helps you to identify patterns in your data, right? And this is a clear pattern. You see that the higher number of projects, the higher your evaluation. Okay. Now we want average. So this time our values of interest is the average monthly hours. This time we want our index to be salary and then columns to be number of projects. Okay. Now when we do that, we also see another trend. Okay. So we have salary here, we have number of projects over here. Right. And what this means is that the more projects you have, the more money you're going to get. And this is true across all salary levels, whether low, medium, or high. The more projects you have, the more money you get. Okay, so this is a pattern we see. So we go to the heat map number 4. In this case, our values of interest is the satisfaction level. We want time spent in company as an index, and then a column is number of projects. Okay. So this one too also tells you. So we see that generally between 3 to 5, they have lighter colors as compared to the rest. Right, they are lighter colors as compared to the rest in terms of comparing time spent in company with number of projects. However, we have something here which is more or less like an outlier, right? So it means that we have somebody who has 7 projects, right? Who has 7 projects, and the time spent in the company is 2. All right. So there is this lighter color here which represents an outlier of some sort, because over here you have 0 0.1, 0 0.1, 0 0.1, and then you have 0 0.6, right, which is not usual, especially in this color. Okay, so that could represent an outlier. But then generally you can see that between 3 to 5, or from 3 to 5, the colors are generally lighter as compared to the 2, then the 6 and 7. Okay, so this is also an insight. So this time I want to do last evaluation across departments and time spent in company. Okay, when you look at this as well, so time spent in company and then across departments. Okay, so this is what you also have, right? So this is last evaluation. Good. So, and over here too, we see that 4 to 6, they generally have people who have spent from 4 to 6 years in the company. On this graph, you can see that it shows that this side is generally darker, than the rest. Okay, this side is generally darker than the rest, right? So that means that people who have spent 4 to 6 years in the company, usually have a higher how do you call it, higher evaluation score, right? Have a higher evaluation score, which could mean that people around those areas have matured in a company, and they know the ins and outs of the company, and so they can do more with less time, right? They become more efficient, they know the ins and how the company works, and so on and so forth. So that can also boost their productivity level. Okay, so that could be a possible interpretation for that. So we have that over there. So this, the heat map number 5 is the life expectancy and GDP per capita. So this is not part of the employee attrition data set, but I just wanted to bring this to demonstrate another powerful aspect of heat map, right? So I got my data from this link. And then this is a table of representing the data set. So I created a pivot table where the index is the continent, and then the columns represent the year, and then the values represent the life expectancy. Okay, so now when we plot it, we see something here. Great. So the life expectancy sort of is just sort of like in every country, sort of like there is an average number of years that people live, right? So that's the life expectancy. Okay. Um. So the lighter color represents lower life expectancy, and the darker color represents a higher life expectancy. Now we have the continents here, and then we have the years over here. And so this is from 1952 to 2007. Now we see a trend. We see that as the years go by, the life expectancy increases, and this is true for all the continents. Okay, but another powerful aspect of heat map is instead of just looking at trends, sort of like looking at the heat map horizontally, we can also look at it vertically. Now let's compare Africa to the Americas. We see that across all the years, Africa is lighter than the Americas. Okay, so we can see that across all the years, the life expectancy in America has been higher than that of Africa, right? We can also see that when you compare the Americas to the Oceania, right, you can see that across all the years, the life expectancy of Oceania has been higher than that of the Americas. So as you observe a general trend across all the continents, you can also compare continent to continent to see which one is doing well than the other. Okay, so that is a real powerful tool right here called heat map. It helps you to uncover so many things right at a glance. And then we do a similar thing, but this time our values of interest is the GDP per capita, right? Over here to very similar, we see a trend, which is from a lighter color to a darker color. And we see that across the years, GDP per capita has been increasing, right? But another insight you can also draw from this is that Africa has had the lowest GDP compared to all the other continents, right? We see that when you compare Africa to Americas, you see that across all the years, America's GDP has been higher than that of Africa. Asia's GDP has been higher than that of Africa. All the other continents' GDP across all the years has been higher than the that of Africa. Okay, so this is a very powerful tool for visualization. It helps you to uncover so many things at a time. One thing you can also do with a heat map is a correlation matrix, right? It helps you to see the correlation between a number of you know a number of variables, right, at a glance. So that is it for heat maps. It was a very short presentation. So I hope that you make use of heat maps in this week's challenge and know that it's a very powerful tool for visualization. So at this here, I'll pause for any question that you might have. I'll be happy to answer them. Any question? All right, so if there's no question, then please feel free to ask your questions in the Slack, and we will end it here. Jean, do you have anything?
Yeah, the only things I have is that I just like the tutorial session because I was even following, and your plots are very helpful to understand, and I want to thank you for that. Yeah. So so we are just going to continue on Slack. Yeah, so that you. But if some of them have questions, like I'm reading,
under the cell 109 section, please, what is the meaning of this FMT?
Come again.
Is someone saying something?
Yeah, I think so. Please, can you ask the question again?
Yeah.
Okay, no problem. So someone is asking, can we use heat maps without need of making pivot table? Yes. So I give an example. Correlation matrix, right, as an example of using heat maps without necessarily, making a pivot table. Right, the pivot table only becomes necessary if you want to compare, if you have a variable of interest and you want to compare it across two other variables, right? That is when you can use a pivot table. But then without a pivot table, you can do a correlation matrix and then, use the heat map to visualize it, to visualize the correlation between a number of variables. Yeah. I hope your question is answered, Janet.
Yeah,
I have a question. I have a question.
Hello.
Okay, just go on.
Can you describe what the arguments for the heat map function are? I don't get what anode FMT and anode KWS mean. Thank you.
Okay, sure, that's fine. Right, so the heat map takes a number of parameters, right? And these are just a few of them. Please, can you see my screen?
We do see.
Right. So the first one is the table one, which represents the pivot table. For example, if you created a pivot table and you want to visualize that, then it takes in that pivot table, right? So this is what we have here. And then the anode is whether you want the numbers to appear on the heat map. You set it to true if you want the numbers to appear on the heat map, right? And then the FMT represents, so if, for example, you have numbers, maybe you can help you to specify the floating point, right? In this case, we said dot 3F, which means that we want our figures to appear as three decimal places, right? So we specify the 3F. And then the anode KOWS represent the size of the figures. So if you decide you want to show the figures on the heat map, you can also specify the figure size, right? And which is what we have over here. I hope that is clear.
Yeah,
Sure.
it's clear. Thank you.
Any other question?
Yeah, I think. Yeah, any other question?
Yeah, question.
Okay. Yeah, so I think someone is trying to talk.
Hello.
Yeah, hello. Aibila.
Yeah,
hello.
Sebastian, can you please go over?
Okay, yeah, I have a question. Concerning the hello.
Please go over.
Yeah.
Okay, yeah. There's something you did when you wanted to index one of the pivot tables. You use something like .I log r something np.r. I didn't really get that point. I think down. When you wanted to index the pivot table for the, I think for the life expectancy, something like that. You put something like .npr something like that. I don't know if you can.
Let me see.
Down, I think no, down. The one that was very short, the pivot table that was short. Down.
Is it this?
No. Wait, can you take two? No, up, please. I can't find it again. No, I saw it before.
Because it's a life expectancy.
I think I can. Maybe I will send it as a message on Slack. I can't find it here.
Okay. I mean, when you go to today's folder, you have this over there, so you can take a picture of it and then you can send it to me, and I'll be happy to.
Okay.
Yeah.
Thank you.
Yeah.
And one more thing.
Sebastian.
Yes, Aibila.
I was saying that just go over one of the examples again one more time.
Okay. Do you have any specific one you want me to go over?
Deriving insight from the plot. So just go over that.
Come again.
Deriving insight from the plot
or the heat table. So
Yes,
just go
yes,
over it one
yes.
more time.
Okay, so let me use the life expectancy. I didn't name my title very well. Um, I need to correct this. And then, okay, so let me use the life expectancy for example. Okay, to demonstrate how powerful the heat map is. So in the start of the tutorial, let me go up here. We said heat map is a type of visualization that uses coloring to show variance across multiple variables. It is useful in detecting patterns, showing similarities between variables, and to identify correlation between variables, right? So what we see here is heat map showing us patterns. So lower figures have lighter colors, and higher figures have darker colors. So we can see that across all the continents, we see that colors get darker as the years go by, right? So it's from 1950. As the years go by, the colors get darker, which means that life expectancy has been on the increase across the years, and this is across all the continents, right? That is one insight you can derive from it. Another insight you can also derive from it. So that's sort of like a horizontal insight. Okay, there's nothing like that, but I'm just trying to call it that way. Horizontal insight. Now, how about it? Do you have anything like vertical insight? Yes. When you compare Africa to America, you can see that generally America's colors are darker than that of Africa, which means that life expectancy across the years for America has been higher than that. Okay, and that is what you can see on this heat map. And that is also true for Asia, Europe, and then Oceania. Their colors are generally darker than that of Africa, which means that the life expectancy has been higher than that of Africa across all the years.
Okay. All right. I think I get it.
Sure, yeah.
Thank you.
You're welcome. Any more question?
Steven, hello.
Yes.
Have you come across any of these tables where you struggle to really make meaning out of it because of how the random things are or something like that?
Yeah, it's possible. So I think I have an example here. I think this, even with this one, you can see a little, trend, which is 4 to 6. So you can see that this place is generally darker than here and from here to here, right? But then there are examples where everything is just all over the place. But even that is also an insight, because that could also mean that there's actually no correlation, or there is no pattern in the data or something like that. So the fact that you don't see any correlation or you don't see any pattern does not mean it's not an insight. It is an insight in itself. Okay.
Okay.
The only thing is that the visualization helps you to understand how you are going to further, further analyze your data sets. So, for example, if you see that there is a lot of patterns between variables, or the correlation between variables are very high, then when it gets to the feature engineering stage, you know that you need to drop features that are highly, that highly correlate with each other. So, for example, if you have feature A and feature B, and then both of them are highly correlated, it means you have to drop one. Do you understand? So the visualization will tell you that these two columns are highly correlated. And what is the implication of that? The implication of that is you drop one of them. Okay. The implication is that we use two of them. Okay. So the visualization informs further process.
Okay. Thank you.
Yeah. Sure. Any more question?
Yeah, I think.
Yeah, I think
I
that's
have a lot of questions, and I actually like that because I saw you very active. And don't feel free to use those kind of things in the weekly challenge if you think about, because we just provide some question to focus on the core things we want to mark, that it will be great to read you about producing some things about health map analysis, for example. So just look at if you have conditions, if you have import in your data set to produce those kind of analysis, yeah, it's very, 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 very good. And so I encourage you and I recommend you to explore as you have time. I know there are a lot of things to do. So just focus on the one you have to do first. And then if you have any extra time, you can try. Yeah. I know these kind of analysis are very helpful in business because I'm experiencing that myself. Pivot table, health map analysis, at least you will use Microsoft Excel to do a conditional formatting after pivot table. So like this kind of formatting, health map analysis actually provide are very useful. So take care of this tutorial and yeah, use it in your real life and whatever, wherever you will be requesting that. So thank you for following this session. I really like your proactive. You are really proactive and you are really active. And I saw you also on track, and I'm happy. I'm happy the way you are doing. So I hope most of you submit yesterday interim solution and keep doing. That's all I will say to end this tutorial. If Sebastian has something to say, yeah, you are welcome.
No, what I'll say is keep your questions coming in, and we are
Yeah.
happy to provide answers.
Okay.
Yeah.
Cheers, guys.
All
Leaving.
right. Yes.